Now we will see the program for serial reception. So during reception, microcontroller is the receiver and PC is the transmitter. The input to the PC is given through the keyboard. So we can give the input as alphabets and the numbers or the special characters. So whatever is the key pressed from the keyboard, its equivalent ASCII value will be displayed on the LED. As it can be seen in this interfacing diagram, here we are using port pin P0.4 as the transmit pin and port pin P0.5 as the receive pin. So for the transmission program that we have seen, the data will be transmitted through the TX line and will be sent to the PC. So we have observed the output on the hyper terminal. For reception, the data will be transmitted by the PC and will be received into the microcontroller through the receive pin over here. So P0.5 will be acting as a receive pin. The PC is going to act as a transmitter. So any key can be pressed from the keyboard and its equivalent ASCII value will be received on the receive line. And this data will be collected in the SBUF 0 register. From SBUF 0 register, we are going to send it to port 4 where we have connected the LEDs. These LEDs, they are connected in the common anode configuration. So to display the data on the LED, it should be complemented and then given to port 4. So we will be complementing the SBUF register and then writing that value to the port 4 register so that we are able to see the ASCII value of the character which is pressed from the keyboard on these LEDs over here. So here we have configured the OSC ICN register to select the maximum clock frequency as 12 MHz. We have configured XBR0 register to enable the UART0 module through the priority crossbar decoder and route the TX0 and RX0 lines of UART0 to port pin P0.4 and 0.5 respectively. The priority crossbar decoder needs to be enabled by writing the value XBARE bit equal to 1 in the XBR1 register. So we are loading the count 0x40 in XBR1 register. Then port pin P0.5 is used as the receive pin. So it should be configured as an input. So value 0x20 is written to the P0 MDN register. We have connected LEDs to port 4. So port 4 should be configured as output. So 0x FF value is written to P4 MD out register. Then as per the hardware, when we connect the connector for LED, the buzzer also gets connected and it makes sound which is not desirous. So to disable the buzzer, here we are configuring port 3 as output because the buzzer is connected to port pin P3.3 and we are writing the value 0x00 to port 3, so it will disable the buzzer. So this is just to taken care to turn off the buzzer so that it doesn't make the sound. Then in the SCON 0 register, we need to enable the receive enable bit. So to enable the reception and select 8-bit UART communication, we are writing the value 0x10 in SCON 0 register. Then we are selecting the prescaler by 4 for the system clock to generate the desired baud rate, that is 9600. So we are loading the count 0x01 in CKCON register. Then we are configuring TH1 to generate the desired baud rate by writing the equation to TH1 as 256 minus system clock divided by baud rate divided by 2 divided by 4. And because this baud rate is generated using timer in mode 2, we need to load this count in the TL1 register. So we are copying the required count from TH1 to TL1. And then we are configuring timer 1 in mode 2 by writing the value 0x20 to the TMOD register and starting our timer by writing 1 to the TR1 bit. Then for reception, first we need to poll for the reception to be over. So this interrupt RI0 is used to indicate end of reception. So while RI0 is equal to 0, reception is going on. So we need to wait over here for reception to be over. As soon as the 8 bits will be received into the SBUF 0 register, microcontroller will make this bit equal to 1 and indicate end of reception. So when the reception is over, the data will be collected or data will be present in the SBUF 0 register, which we have to send to port 4. So here, using the statement while RI0 equal to 0 semicolon, we are polling for the reception to be over. So till the time reception is going on, control will be in this loop. As soon as reception is over, RI0 will be made 1 by the microcontroller and control will come out of this while statement and come to this P4 equal to naught of SBUF 0. So as I have shown you in the interfacing diagram, because the LEDs are connected in common anode configuration, we need to complement the value of SBUF 0 and then send it to port 4. So we are sending the value complement of SBUF 0 to P4. And once this is done, we need to clear the RI0 flag for the next iteration. So again, RI0 is going to be set by the microcontroller, should be reset by the programmer. So now we will download this program. So to download it, first I will build this code. So here you can see I am getting the message as build finished, and now we will download this into the controller. So here again, this is the development board. I will bring this to the bootload mode, and here in my bootloader over here, so this option is enabled. So here we will click open and browse the hex file. So this is the receive hex file. Click open and download. So now the hex file is downloaded. Now we need to observe the output. So we need to bring the microcontroller board in the run mode. So for that I will press this switch. The UART module should be connected. So we will use this programming cable and connect it to the UART connector over here. And also we need to observe the output on LED. So this is the peripheral board that we are having. These are the SMD packaged LEDs that we are having, and PL8 connector of this board is connected to the LEDs over here. And from the development board we are going to use this PL6 connector to connect the LEDs. So I am going to use this FRC cable and connect my PL6 from the development board to the PL8 connector of the peripheral board. So here now this peripheral board is connected, and yet I have not pressed the reset from here. So I will press the reset to bring the board in the run mode. And now to observe the output, we have to give the input from the keyboard of the PC. Okay. So to give the input, again we will have to configure the hyper terminal. So hyper terminal acts as an interface between the PC and the board. So let me just configure this hyper terminal connection. Okay, so here we have got the connection name. So I will give the name as receive over here. We can give any name of our choice and click on OK. Again it is asking for the location information, which I will cancel. Yes, OK. So it is asking me connect to, so I need to connect it to COM3. So I will just click on OK, and these are the port properties that we are getting. So again we have set the baud rate as 9600 in our program. So we will keep this as it is. Data bits is 8, parity is none, stop bit is 1, and flow control is none. So this will be OK over here. Now you will see when I press the any character from my keyboard, its equivalent ASCII value is going to be displayed on the LED over here. Okay, so here let's say if I press this character A, right now my caps lock is off, so I will press this character A, and here you can see on the LEDs over here we are getting the value as 01100001. Okay, so here this leftmost bit is the LSB and the rightmost bit over here is the MSB. So we have to read the value as wait, let me adjust this view properly. Yes, so now you can read this. So it is 01100001 from right to left. I have read it from right to left. So MSB bit is 0 followed by 2 ones followed by 4 zeros and then a 1. So this is equivalent to 61 in hexadecimal, which is nothing but the ASCII value for small a. Okay, but right now you can see on my hyperterminal I cannot see any character. So for this we need to turn on the echo. So to turn on the echo, we will go to this option file, click on properties, and here go to settings and enable the option echo typed characters locally. So whatever we type from the keyboard will be displayed on the hyperterminal window, and also its equivalent ASCII value we will be able to see on the LED. So let me just press the number 0 over here. So here you can see I have pressed the number 0. And here on the LED you can see the ASCII value for 0 coming, which is 30H. So again we have to read it from right to left. So this is 0011, that is 3, and then 0000, that is 0. So this is 30H in which is the ASCII value for 0. Similarly, if I press capital A, so here you can see on the hyperterminal window I have pressed A from my keyboard, and here I am getting the ASCII value for capital A, which is 41 in hex.